Hi, I'm Randy Bone. I'm an embedded firmware, hardware, microcontroller engineer, contract consultant type basis. This is to basically tell you who I am. My contact information, my website is rlbone.com. I run two blogs, one called Picking Bones, which is a blog devoted to the microchip PIC family of processors and technologies, and another one called Embedded Bones, which is just about the industry in general and all of the technologies related to microprocessors, microcontrollers, and their and associated things of interest. Contact information is on the screen. My phone number is 256-613-2034 if you're interested. This video basically is an overall introduction. There's other videos that I do which delve into details about other things. But for right now, I'll say that I basically specialize in the microchip PIC family of processors, and I work with that technology most of the time. My primary working language for firmware is C. That's kind of universal for all microprocessors these days. I also do some assembly occasionally, but not too much of that anymore. In the old days, of course, it was all assembly, but in recent years it's pretty much all C. C++ is also getting to be of some interest in this area. I have done C++ on ARM in the past, but generally for 8 and 16-bit micros, there have been no C++ compilers available. Microchip's PIC32 family of line does have a C++ compiler, so I expect to be doing more C++ in the future, but primarily now my working language is C for microprocessors. While I'm not a PC programmer, really, I do write some PC code now and again in support of macros. And when I do that, generally it's in C++. And I do that for testing microprocessors and the like. Also, something that I do a lot of is microprocessors or microcontrollers, embedded systems to control machines, monitor processes, things of that nature across the internet, or Ethernet in general, but usually the internet. And generally people want to do that from a web browser on Windows or Linux or something. So I also create web pages on a PC. I create web pages that I serve on an embedded server, usually a PIC embedded server of some kind, and to allow you to operate, to control your system from a web browser someplace. I generally do that on a PC and in a variety of languages. I write a little bit of HTML, but that's usually not very practical. You can do a good job on that, and even in Microsoft Word, you can create a web page quite nicely in Microsoft Word. Something that's a little more convenient for this sort of thing is Microsoft Visual Studio, which I use that quite a bit for that sort of for developing web pages to be served on an embedded server. I've also worked with most communication systems for computers and microcontrollers and electronics in general. I've designed with, of course, Ethernet for the internet, USB, and then all the things like SPI, I2C, CAN, and pretty much all of those, plus some, in the old days, some protocols of my own, which I dreamed up. But I'm pretty versed in all of those. I will be doing other videos to delve into each of these communication systems in more detail, but this is a general overview. All my videos will be posted on my website at arielbone.com, so anybody that's interested in any particular video can find a link to it there. I also have a long background, of course, in industry and various kinds of things. I started out in aerospace back in the old Saturn Apollo days, back in the late 60s, early 70s, and through the 80s there. Pretty well, I worked with that pretty much to the end of the Apollo program. Manned and unmanned spacecraft and satellites. In aerospace, in more recent years in aerospace, I've also been involved in radio astronomy. Did some work for the National Radio Astronomy Observatory in New Mexico, around the famous VLA, Very Large Array. I also did some stuff for the ALMA project, which is now in Chile. Also, there's another video that delves into that in more detail. Also have many years of experience in heavy industry. I worked for Olin Corporation for a long time, for 15 years. They were doing, of course, Olin is a conglomerate doing lots of things. I was based at the Augusta plant in North Carolina, which was a paper mill. I did a lot of stuff for pulp and paper technology. Primarily, I went into there just designing industrial laser systems. The business they were in at the time, processing paper by CO2 lasers, commercial, high power industrial lasers was an important thing. So I did a lot of work there for them, designing laser systems, controllers for lasers, that kind of thing. That was kind of the transition period between discrete or TTL type design and microcontrollers. I did part of that work, just an old-fashioned TTL transistors and 7400 family TTL chips, and CMOS. That got changed over in the mid-80s, really, when the PC came out. It became practical to do more computer-type stuff with industrial controllers. So I did that. Then shortly thereafter, when the 8081 showed up, for the first really usable 8-bit microprocessor, and we started using those to do embedded boards. And I've been really with it ever since. In those early days, I went through the 8051s, the 6800s, and those 8-bit kinds of things. Later on, in the late 90s, early 2000s, I discovered the PIC, and it was pretty obvious to me that RISC was the future, and PIC was going to be dominant. So I've been pretty much specialized in PIC since then. Starting out with the very early 8-bit devices, and the early versions of MP Lab using all the programming in assembly language and such. That progressed through the years. We switched over then to pretty much all C a few years later. Nowadays, I've done a lot with pretty much all the 8-bit devices. The PIC-16s, mid-range family, the PIC-18s. I've designed a lot of consumer applications in those things. Things like controllers for refrigerators, appliance controllers, various handheld devices for whatever people want. Whatever the customer wants, I do. Also, and then the PIC-32, the PIC-16s came out, PIC-24 family of 16-bit processors, and I've done a lot with those, designing internet devices, controllers, monitors for monitoring hazardous gases and biohazards and various kinds of things that you will monitor with those kinds of devices. I've also done motor controllers, and especially with the DS-PIC. The DS-PIC came along for digital signal processing. That's a neat little device. Of course, when it comes to performance, milk will rise. It can't touch something like the TIs or the analog device units or something like that. But it's much less expensive and easier to deal with. And you can get more than you get quite a bit of performance out of that. It's good for all but the most demanding sorts of DSP applications. So I've done things with the DS PIC. And now the PIC 32s, they're coming along, done various things there, which kind of moves us into the development systems of Microchip. MP Lab, of course, has been their development system from the beginning. I've worked with all the versions of MP Lab through the years, up until the latest version of what was the conventional MP Lab, which is MP Lab 8, it was a good run. And I still have MP Lab 8 on my machine, on my development computer, and some people still do some things with it. I do some legacy work with it, and occasionally I have customers or clients who have a lot of nostalgia for that system, so and some people still use it. But MP Lab X has taken over now. Microchip no longer supports any MP version except X. So myself, and when I have a choice, I pretty much changed over to MP Lab X. As I say, that gives you a lot of advantages there as a more modern system. Things like if you want to do code generators, things like working with things like MATLAB or Scilab or some of those kinds of things that can generate code from mathematical formulas. MP Lab X handles that much better. And it's more of a modern system. You do have to accept some FM. I mean, it's kind of like Windows. And it's like programming in Windows. A lot of times you don't really know what's going on. You just have to take their word for it. As an old-time embedded guy who's used to wallowing around in the silicon, I don't like that much, but I do understand that you have to accept it to some degree. I mean, the times move on, and this stuff gets so complex you can't keep up with every nook and cranny of it. I've also done a lot of teaching. I was adjunct faculty in the North Carolina Community College system for 8 years. I taught electronics, digital, analog, microprocessor, microcontrollers, programming, C and assembly, C++, analog electronics, things like op amps, industrial control systems and the like. Yeah, I do a lot of hardware work as well. I design electronics for many years. I've done a lot of schematic capture work. I work with OrCAD, Protail/Altum, all PCB Express and some of those free ones. And plus, in the old days, I've of course drawn schematics by hand with pencil and paper. And over the years, as times have changed, I've done pretty much all of it. So hardware is not an issue for me. I've designed boards. Today, primarily, I design boards that support microprocessor, microcontroller systems of some kind or another. Put the processor on the board, and add whatever other components that might be needed to make the system function. So I'm comfortable with hardware. Just a quick laundry list of some of the things I've done. There's other videos that go into these in more detail, but I've done a lot of machine vision, automated inspection, capturing images and processing them to get certain information out of them. I've done photography type design cameras for various purposes. like glue logic, is putting processors onto boards as part of a larger system. Interfaces of various types between communication systems. I've done CAN to SPI interfaces, SPI to I2C, Ethernet to serial, on and on. So yeah, I've done a lot of those kinds of things. I'm minimizing, trying to keep this video reasonably brief, but there are other videos. I have links to other videos and other writings on these subjects on my website if there's interest.